Hello, how are you? Today, inshallah, we will take 18.2 modern evolutionary classification. So, we will, inshallah, learn how to classify organisms in the modern evolutionary theory. For my objectives today, I need you to explain the difference between evolutionary classifications and linear classification, and at the same time explain the use of DNA sequences in a classification. Let's start with our lessons by evolutionary classification. In the previous lectures, we took the previous classification, and today, inshallah, we will take the evolutionary classification. So the concept of descent with modification led to phylogeny. What do I mean by phylogeny? Which is the study of how living and extinct organisms are related to one another. At the same time, advances in phylogeny is term led by phylogenetic systematics or evolutionary classification. So, evolutionary classification, which is the phylogenetic systematic, which is branched from the phylogeny in general. And phylogenetic systematics groups species into larger categories that reflects lines of evolutionary descent rather than overall similarities and differences. And in the same time, a clade, which is a group of species that includes single common ancestor. So again, a clade is the group of species that include single common ancestor. And all descendants of that ancestor living and extinct is called a clades. Okay? As you can see in the picture, here we have a clade mammalian. So this is a clade village, clade carnivora, clade mammalia, clade animata, clade tetrapoda. Okay, so this is a common. This clades have same or common ancestor. This is have common ancestor and so on. And you have here a point called node. What you mean by a node is a point at which two grouped branches from each other. And here we have derived character, and you have to know how to differentiate between each clades. For the common ancestors, we say that phylogenetic systematic place organisms into higher taxa whose members are more closely related to one another than they are to members of any other group. So again, higher taxa with phylogenetic systematics. Okay, so again, phylogenetic systematics places organisms into higher taxa whose members are more closely related to one another than they are to members of any other group. The larger a taxon is, the further back in time all of its members share the common ancestor. So again, the larger a taxon is, the further back in time all of its members share the common ancestor. And let's start right now with the cladogram. What do you mean by cladogram and how we can build a cladogram? So modern evolutionary classification uses a method called cladistics analysis to determine how clades are related to one another. Okay? So this information is used to link clades together into a picture called cladogram, which illustrates how groups of organisms are related to one another by showing how evolutionary lines or lineage branches off from common ancestor. So how we can build a cladogram? So a speciation event in which an ancestral lineage branches into two new lineages is the basis for each branch point, or we can call it node. Each node represents the last point at which the new lineage shared a common ancestor. And we have a splitting event, ancestral lineage. You have to check it here. A cladogram is a branching patterns indicate degrees of relatedness among organisms. As you can see here in the picture, 3 and 4 shared a common ancestor. And also the line between 3 and 4 will attach to 2. So there is a common ancestor between 2 and the lineage of 3 and 4. And the lineage of 2, 3, 4 is attached to number 1. Okay? We will watch a video on how to build a cladogram, okay? And I want you to focus on this point that it mentioned already in the video.
How to build a cladogram. First, choose a set of organisms. Observe them carefully and list how they are different and how they are alike. For example, you might find that some organisms have backbones and others don't. Some organisms have hair and others don't.
To find the point of matching, you need to find the characters that are shared between these organisms, okay? Come on, let's complete.
As you observe these different characters, you can start to fill out a data table to indicate the character states for each organism. With this data table, you can then sort your organisms into bins.
Focus on the shared characters. So here we have the eggs, backbone, warm-blooded, and hair. And here the organisms that they have these things or not, okay? You have to find which organism shared all of the characteristics and which characteristic exactly is shared between fewer organisms, okay?
Based on the characters you use to compare them. For example, all the animals in this bin reproduce through eggs, but only these ones have both eggs and a backbone. And only these ones have eggs, a backbone, and are warm-blooded. And of these, only 2 have hair. Eventually, you'll have
the characters shared between these 2 organisms is different from the characters shared between these 3 or 4 or even 5 organisms, okay?
created a Venn diagram that you can use to draw a cladogram.
Venn diagram, we can form cladogram. After finding the sharing characteristics, we will form the cladogram.
Just like the Venn diagram, our cladogram shows how all organisms reproduce through eggs, but only these ones have both eggs and a backbone. And even fewer have both eggs, a backbone, and are warm-blooded. And of the remaining organisms, only 2 have all those characters as well as hair.
From the Venn diagram, we can form the cladogram. So these 2 organisms have the hair. Here they are warm-blooded, all these 3. Here these organisms have backbones, while this one with all of these have eggs, okay? This is how to build the cladogram. Make sure you understand this point and try to solve many examples from the books about how to build cladogram. And have a nice day. Thank you guys. Bye bye.